Dear friends, I myself, Dr. Bharat Parab, discussing the topic proofs in mathematics. This is given in Appendix 1, very important topic, okay, and very intelligent concept, okay. So we will start with this, start with some examples, and as we move ahead in this video, we will come to know that this topic has been made very easy by me, okay. Now think on these examples. Okay, read this very carefully. There are three examples. Okay, first one, this is a statement. A shirt belongs to your friend. Okay, why? Because many people saw him wearing frequently. Okay, here opinions may vary from person to person. This statement depends on the opinion from the people. Okay, so here opinions may vary from person to person, hence cannot prove with documents. Okay, simple statement. Second one, your friend might claim that the book you have actually belongs to him. Okay, when you may show him the shopkeeper's receipt. This is better than the first example. Okay, here it was just opinion. Here you are giving some proof. Okay, but that receipt might belong to another book also. Okay, so this is some improvement here in providing proofs, and we are trying to see how the proofs in mathematics are built up. Okay, and third one, a policeman asks for PUC of your vehicle. You are bound to produce a proper document given by an authorized person with the number of your vehicles. Okay, got it? You must have come across such type of examples in your daily life. Okay, so in this example, nobody can challenge the document. Okay, so see the difference between these three examples. Okay, now same as in example 3, example 3 where we cannot challenge the documents of our PUC. Same as in this, mathematics asks for proofs which cannot be challenged. Okay, but to do this, we accept some statements without proof. Okay, because these are self-evident truths. We will come across this term self-evident truth in the further part of this video and try to understand this properly. Okay, and are called as axiom or postulates. We will also come across these two terms in this topic frequently. Okay, now let us start with the definition of statement. Okay, let us see the definition of statement. Consider these quotes. First one, how old are you? This is a question, cannot be statement. Second one, bring me water. This is either order or request. Again, this cannot be statement. Third one, very nice dress. Okay, exclamatory. Again, this cannot be statement. But the fourth one, you are going to school. This is the statement. Okay. Hence, statement in mathematics are either always true, always false, or ambiguous. We shall discuss the term ambiguous now. Okay. So, this is always true, or always false, or ambiguous. Okay. So, this is the definition of statement. So, we have seen about the statement that it can be always true or always false or ambiguous. So now we will see what is ambiguous. We cannot decide whether the statement is true or false. Okay, so there are two examples. We will go through this. Okay, first one, tomorrow is Monday is an ambiguous statement as we cannot say whether the statement is true or false as we do not have enough information, because this statement is true only if we utter it on Sunday. Okay, but the statement does not specify that when this was uttered. Okay, so this is ambiguous statement. Second one, dogs are intelligent, is again an ambiguous statement, as for some this statement might be true, but for some it may not be. Okay, so this is an ambiguous statement. So these are two ways by which a statement may be ambiguous. Okay, why we are doing all this is because we are trying to discuss how proofs in mathematics are given which are acceptable to all and free of doubts, not like this. Okay, so that is what we are trying to achieve. Now read this very carefully. To clarify the concept of statement, we would see some statements and check for its truthness. Okay, first one, we will see statement and then the answer. Okay, one by one. First one, the statement is there are 8 days in a week, and the answer is, first one, this statement is always false as there are 7 days in a week. Okay, second one, the sun rises in the east. Answer, this statement is always true as sun rises in the east in all circumstances. Okay, third one, Amit is a wise boy. The answer is, third one, this statement is ambiguous as for some people Amit may be a wise boy, but for some he may not be. Okay. Fourth one, it is raining here. Okay. Now, fourth statement, this statement is ambiguous as we do not know where here means. Okay. We cannot say what is here. Okay. Now answers are continued on the next slide. We'll just go through this. All even numbers are divisible by 2. Okay, and the product of two odd numbers is even. We'll see these answers for these in the next slide. Okay, now the statements continued from the last page, rewritten from last page. Okay, fifth one, all even numbers are divisible by 2. Answer, this statement is always true as all the even numbers are divisible by 2. Okay. Sixth one, the product of two odd numbers is even. Answer for this is, this statement is always false. There is one example given here. 3 into 5 is 15. Okay, it's not even. Okay, so only one example is sufficient to prove that a statement is false. Okay, now there is some quote here. If someone says it's very hot in Mumbai, okay, try to understand this very thoroughly. Okay, if someone says it is very hot in Mumbai today, it may not be hot for a person from Delhi as he faces very hot temperatures than in Mumbai. In Delhi, he must be facing very hot temperatures. Okay, then he may feel that the statement is not true. Okay, but for a person from Canada, the statement may be true as he has never experienced these high temperatures in Canada. Okay, so this is a personal opinion of many people. Okay, This is yet another example of ambiguous statement. Okay. Now try to understand this statement very carefully. Okay, I'm just reading it. Mathematical statements cannot be ambiguous. Okay, like this. In mathematics, a statement is only acceptable or valid if it is either true or false. Okay, that is, if a statement is true, it is always true. Otherwise, it is called a false statement. Okay, now you may read this once or twice. Okay, you will understand this. Okay, now look at this. The first known proof was given by a Greek philosopher and mathematician Thales. This is that person. Okay, Thales, 640 BCE to 546 BCE. Now consider these examples. 6 plus 3 is 9 is always true, and 6 plus 3 is 8 is always false statement. Okay, so we will now deal with statements which are either true or false and not ambiguous. Okay, now let us solve some exercise. State whether the following statements are true or false. First one, the sum of the interior angles of a triangle is 180. Now consider this triangle and these are interior angles here. Okay, the answer is this statement is true. True means always true. Okay, and as a comment here, we have proper proof for this. Okay, we have proved this in this topic. May not be in this video, but maybe in some other video, but we have proof of this statement in this. Okay, second one, every odd number greater than 1 is prime. Answer, this statement is false. Okay, as for example, 9 is greater than 1 but not prime, and one example is sufficient to prove that statement is false. Okay, third one, for any real number x, 4x plus x is equal to 5x. Okay, answer, this statement is true, always true. Okay, and fourth one, for any real number x, 2x is greater than x. Answer, this statement is not always true. That means it is false. Okay, and can be proved to be false for at least one value of x. As for example, if x is equal to -1, we get 2 into -1 is equal to -2, and -2 is not greater than -1. That is where the statement fails, and hence this is a false statement. Okay. Fifth one, for any real number x, x square is greater than or equal to x. Answer, this statement is not always true and can be proved to be false for at least one value of x. Okay, as for example, if x is equal to 1 upon 2 or half, we get 1 upon 2 the whole square. Okay, like this is equal to 1 upon 4, and 1 upon 4 here is not greater than 1 upon 2. Okay, this is where statement fails. Okay, and sixth one, if a quadrilateral has all its sides equal, then it is a square. Okay, answer, this statement is false since rhombus has all sides equal. Okay, all equal sides, but need not be square. Okay, this rhombus all sides equal. Okay, and it's not square. So this statement fails here. Okay, There is an important comment here. We need one example to prove that statement is false. And this example is called as counter example. Okay, but some of the examples in these, okay, we'll read this. Now, some of the above examples can be proved to be true under certain conditions, and we will check for these conditions now. Okay, we'll take some of these examples and see that they are true but under certain conditions. Okay, now we are taking some of the examples given earlier and looking for the conditions under which these statements can be true or always true. Okay, first one, for any real number x, 2x is greater than x. This is fourth in the series, and this I am repeating this answer. Okay, this statement is not always true and can be proved to be false. This statement. Okay, for at least one value of x, that is for if x equal to -1, x takes the value -1, then we get 2 into -1 is -2, and -2 is not greater than -1, so statement fails. Okay, but if we change the conditions as, see, repeating it again, for any real value of x, 2x is greater than x if x is greater than 0. Okay, then 2x is greater than x is always possible. Hence, this can be considered as true statement. Okay, what is, so this is a condition. And second one, for any real number x, x square is greater than or equal to x. This is the fifth one in that series. Okay, repeating the answer given in that answer, this statement is not always true and can be proved to be false for at least one value of x. That is for if x equal to 1 upon 2 or half, we get 1 upon 2, the square is 1 upon 4, see here. Okay, and 1 upon 4 is not greater than 1 upon 2. So we have seen this in last slide. Okay, now under what condition this statement can be true? Read here. But if we change the condition as x will not take the values between 0 and 1, that is if x is less than or equal to 0, okay, and x is greater than or equal to 1, that means x is not taking the value between 0 and 1, okay, then x square is greater than or equal to x is always true statement. Okay, so we have seen the condition under which the statements can be true. Okay, third one, if you divide a number by itself, you will get 1. The statement. Answer, this statement may not be always true, as if 0 upon 0 is not equal to 1. It cannot divide by 0. Okay, as a division by 0 is indeterminate. The term indeterminate will be taught to you in higher studies. Okay, but if we change the condition as, okay, if you divide a number, you're taking the same thing by itself except 0, okay, we will not divide by 0. If you put that condition, then you will get 1, okay, under this condition, then this statement is always true. Okay, got it? And fourth one, if a quadrilateral has all its sides equal, then it's a square. We have seen this. I'm just repeating this answer. This statement is false since rhombus has equal sides but need not be square. It's a rhombus. Okay. But now if we change the condition for this, okay, see here. Now if we change the condition as if a quadrilateral has all its sides equal and interior angles are equal, then it is a square. Got it? If you put some other condition that interior angles are also equal, then it is a square. This statement is always true. Okay, it's like that. And the fifth one, the angle subtended by a chord of a circle at a point on the circle is 90 degree. Okay, answer, we will see the meaning of this here. Okay, in answer this is a circle, this is a chord, any chord, and this is what we call as a angle subtended by a chord on a circle. Okay, so what it says is all chords subtend angle 90. Okay, so this is not always true statement as all chords do not subtend angle 90 at the point on the circle. Okay, so if chord is small, then it will not subtend angle 90, but its diameter which subtends angle 90 at a point on the circle. Okay, so this is a particular case of diameter. Diameter is a chord, and diameter, then it subtends angle 90. Okay, so we need to change the statement as the angle subtended by a, not chord you have to strike out, diameter of a circle at a point on the circle is 90 degree. Got it? So we have changed the statement from this to this by changing one word. Okay, now we will solve some problems, okay, or exercise. Now exercise 1, state whether the following statements are always true, always false, or ambiguous. Justify your answer. First one, there are 13 months in a year. Answer, this statement is false because there are 12 months in a year. Second one, Diwali falls on Friday. Answer, this statement is ambiguous because Diwali may or may not fall on Friday. Third one, the temperature in Magadi is 26 degrees centigrade. Answer, this statement is ambiguous because temperature in Magadi may be 26 degrees sometimes but may not always. Okay. Fourth one, the earth has one moon. Answer, this statement is always true. Fifth one, dogs can fly. Answer, this statement is false as dogs cannot fly. Sixth one, February has 28 days. Answer, this statement is false because in a leap year, February has 29 days. Okay, so we move ahead. Second exercise, state whether the following statements are true or false. Give reasons for your answer. First one, the sum of the interior angles of a quadrilateral is 350 degree. Answer, this statement is false because the sum of the interior angles of a quadrilateral is 360 and not 350. Okay. Second one, for any real number x, x square is greater than or equal to 0. Answer, this statement is always true. Third one, a rhombus is a parallelogram. Answer, this statement is always true. Fourth one, the sum of the two even numbers is even. Answer, this statement is always true. And fifth one, the sum of the two odd numbers is odd. Answer, this statement is ambiguous because we have to give at least one reason to make this statement false, and this is 1, 3 plus 1 is 4, not always odd. Okay. Third exercise, restate the following statements with appropriate conditions so that they become true statements. There are some statements given and they are not always true. We have to change the condition appropriately so that the statements will be always true. Okay. Look at this first statement. All prime numbers are odd. Answer. All prime numbers are odd except 2. Okay. 2 is a prime number but not odd. Okay. Or all prime numbers greater than 2 are odd. Okay. Second one, 2 times a real number is always even. Answer, 2 times not real natural number is always even. See, this is natural number series 1, 2, 3, 4 like that. Okay. Third one, for any x, 3x plus 1 is greater than 4. Try this yourself. Okay. Answer, for any x greater than 1. Okay. This is true. 3x plus 1 is greater than 4. Only x has to be greater than 1. Okay. And fourth one, read this very carefully. Try to follow the answer very carefully. Okay. For any x, x cube is always greater than or equal to 0. Okay. Answer, if x is positive, then x cube will be positive. Hence, x cube will be greater than or equal to 0. But if x is negative, then x cube will be negative and x cube will be less than or equal to 0. Okay. So these are the conditions. So hence, appropriate statement will be, right statement will be, for any x greater than 0, greater than or equal to 0, x cube will be greater than or equal to 0. Okay. So x has to be either 0 or greater than 0. Then only x cube will be greater than or equal to 0. So we have changed the condition from here to here. Okay. And the fifth one, in every triangle, a median is also an angle bisector. Okay. Answer, look at this statement, in every triangle. Okay. Answer, look at this triangle. Median BM is not angle bisector. Okay. This is smaller than this. Okay. Now in this triangle, median PS does not bisect angle. This is smaller, this is bigger. Okay. Now this is a equilateral triangle. Okay. For equilateral triangles, all medians EH, GJ and FI, they bisect the angles. Okay. This is true for equilateral triangles. So hence the appropriate statement will be, so we are changing the statement so that this will be always a true statement. Okay. In every, not only triangle, but every equilateral triangle, a median is also an angle bisector. Okay. Got it? Okay. So we move ahead. This is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic of proofs in mathematics given in Appendix 1, let me know through comment section and I shall solve it. Thanking you. Good luck.